Hello everyone, welcome to the Go Code Snippets channel. This channel is all about the Go programming language. If you are new to the channel, make sure you subscribe and also hit the notification bell so when I release new videos, you'll be the first to be notified. And after watching this video, if you like the video, hit the thumbs up and also share the video. So today we'll be talking about regular expressions in Go. So the prerequisites to watching this video is you having a little bit knowledge about regular expressions. Regular expressions in most languages actually work the same way. Regular expression strings or regular expression patterns are actually most programming languages are the same thing. So I don't know the languages that I've actually worked with, the regular expression patterns are actually the same thing. I know the one for Go, regular expression patterns work the same way in Go, in JavaScript, and also in MySQL because I've actually written regular expression codes in JavaScript before, and it works the same way with Go and also in MySQL. So I don't know about the languages out there, but I'm very sure most programming languages have the same regular expression pattern out there. At least most C family programming languages, because JavaScript is also a C family programming language, and I've also seen regular expressions in JavaScript and they work the same way with Go. So that is the first thing I would like to mention. So if you don't have knowledge about regular expressions, just you can watch a quick video on how regular expression works and also see some regular expression patterns, the basic ones. So with that, let us move on. So we're talking about regular expressions in Go today, and there is a function, there's a package in the standard library called package regexp. Yes, package regexp. So it is used to regexp. It's used to deal with regular expressions in Go. So that's the package you'll be using today to work with regular expressions. So the first function in this package I want us to talk about is the function match and the function match string. So if you look at documentation for function match, or let me just say go dot regexp. Let's just look at documentation for the whole package. So in package regex, I have func match and func match string. So what func match does is takes in the pattern, which is the regular expression pattern, and it takes in a slice of bytes and it returns a match. That means if the pattern matches the string or the byte slice of bytes and returns an error. Then match string also does the same thing. The only difference is that this one takes in a slice of bytes while this one takes in a string. So we're using match string just to make our code straightforward, more straightforward. So we'll be doing matched comma error should be a result of regex match string. So the expression I'll be passing first is just a simple regular expression. I like using backticks because they hold backticks actually are multi-line compared to double quotes, and it can actually nest a backtick in a backtick, but it can't nest a double quote in a double quote. So the first one I'll be doing is just this. So what this means is that you should just check if there is a number in the string I want to pass. So the string I want to pass is 1, 2, 3, GHF 4. Anything at all. Let me just do it GHF 4 and BH. So what this just does is just look for if there's a number in this particular string. So this expression here, that is what it means. Just like I said earlier, if you don't understand regular expressions, you can just watch a quick video on how regular expressions work and some regular expression. And I also have a website that is actually really good for testing regular expressions. So the name of the website is regex101.com. So it actually takes documentation. So this website here, you can actually go to this website and test your regular expressions against different matches when you are actually working on a production code. So if the error is not equals to nil, so we just see if there's an error. So we just print the error. And then we'll return. Else we just print the match. So I'll run the code and see what we have. So we're having true. That means there's a number in this particular string because the expression we pass in is to check if there's a number at all in the string. So another way we can actually use this is also there's actually a backslash d. So backslash d is also means match all English numerals or all English numbers. So in regular expressions. So if you run this, you should still be having true. So we are still having true. So that is that for match string. So if we go back to the documentation of the regexp package, let us just check the documentation for match or match string, still the same thing. So this particular part what I want us to take note of, it said more complicated queries need to use compile and the full regex interface. So what is the regex interface? Let us just check the documentation for the regex interface. Regex. So this is just the regex interface, which is just this regex struct here. So to get a type regex, we can use the functions compile. I use the functions compile posix, must compile, and must compile posix. So the difference, most times the one that I do come across with, at least most of the codes I've seen and most of the codes I write when I'm using regular expressions, is most times compile and must compile. So the difference between the two of them is that when you use compile, if there's an error, it throws an error, while must compile throws a panic. So if you're using must compile and an error occurs, it will just shut down the whole program. But if you're using compile, it's going to throw an error instead of it to panic. So if you're actually working on a program that whenever there's an error due to a regular expression, you want the whole thing to shut down so the program will continue execution, maybe must compile is the way to go. But if there are some cases whereby even if an error occurs, you still want to continue with the execution of the program, then you can use compile. So with that, we'll be checking out compile and must compile. So in this video, I'll be using must compile instead of compile. So it just helps us just help us handle the error and throw the panic if there's an error. So I'll just create a regular expression. So I'll just say regex should be from package regex. So I'll be using must compile. So this must compile now takes in a an expression which is regular expression, which is a string. So I'll use the one I used before, or let me use an expression to take in to match all English alphabets. So I can just say A to Z, A to Z. So what this means is all English alphabets, whether lowercase A to Z, that's lowercase A to Z, or uppercase A to Z. So if I also put 0 to 9, that means I'm matching all alphabets, upper and lowercase, and also all numbers 0 to 9. So I've created my regular expression. So I can actually call. So if I have a pointer to regular expression, I have all these methods on it. I have method copy, method expand, method. So the method I want us to take a look at first is the methods match and methods match string. So I can do match and match string. So match and match string, they are basically the same thing. The only difference is that match uses slice of byte and match string uses a string, just like the function match and function match string. So I can just print. So I can just print regex match string. So we want to see if the string we are passing in contains. Okay, let me just say, let me use alphabet only since we've used numbers before, just to make it a little bit clearer. So we just see if this string here has an English alphabet. So I'll say 1 2 3, then T, 6 8 or 6 7 8, then Y. So I'll run the code. So you should be having a true because the expression says match check to save. Look. So the expression says check in the string if there is an English alphabet, whether upper or lowercase. So I'll run the code. So we're having true. That means it's actually an English alphabet, whether upper or lowercase. So I can change this one to uppercase also, uppercase Y. Let me just take this one out. So we'll still be having a true. So that's it. I'm still having a true, even though it's an uppercase Y, because I said I want to put for lowercase and also for uppercase. So the next two functions I would like us to check is, so going back to our regexp interface. So the next two functions I would like us to check are the functions replace all string, then replace all func, and replace all string func. So these four functions, replace all and replace all string, are also the same thing, but replace all uses slice of byte, replace all string uses string, then replace all string func and also replace all func are also the same thing, but they just use slice of byte. One uses slice of byte, replace all func uses slice of byte, while replace all string func uses strings. So what replace all just does is, so in our replace all takes in a source and also a replacement. Let me use replace all string. It takes a source and also a replacement string and it returns a string. So what it does is just, let me first try the code and I'll explain what it does. So I'll do str should be equals regex replace all string. So the source is just the string I want to check. So let's say I want to check for, let's see which string. Let me say E I O U, just the vowels. And what I want to do is I want to replace any match here. Or let me put a number in between also. 6. So I want to replace them with a 5. So what this is just saying is that check for, so we'll print out our string. So what this string is just doing is, what this particular line of code is just doing is just going to look into this source, which is this particular string here, then look for every match that this expression has in this string, then change them to 5, and it returns this string back. So here our A will become 5, our E will become 5, our I will become 5, our O will become 5, and our U will also become 5. So I just replacing, so I'll run the code. So I just replacing any match that we have from this regular expression with the 5. So we're having 5 for every English alphabet we have, either upper or lowercase, because our regular expression says upper or lowercase. So that's how replace all string works. Then replace all string func. So what that does is replace all string func. So what this one does is takes in two arguments. Replace all string func takes in the source and also replacement. So what this replacement does is just a replacement is just a func that takes in a string and returns a string, then returns a string, then the whole function returns a string. So what this replace all string func just does is it searches for every match from regular expression in this source, then carries out whatever this function is, carries it out on this particular source, then returns the source. So what that means is, to understand my English, so I'll just passing strings to from package strings and passing the function to upper. So let me make this one only lowercase, strings to upper. So I have to import package strings. So if I run this code, let's see what we have. So I'm having all my lowercase alphabet in uppercase. Why? The reason is because what this particular line of code says is that check, compile the regular expression first, then check any match that we have based on regular expression in this source, then convert all of them to uppercase, because this regular expression actually matches only lowercase. So we have lowercase a will be converted to uppercase because strings or to upper takes in is actually a function from package strings. So upper is actually a function that takes in a string and returns a string, and that is what our replace all func wants, a function that takes in a string and returns a string. So you can also write our own custom strings also to do the same thing. So let's say I'll write a function double. So my function double takes in a string and returns a string. So what my function double does is just doubles the string. So I'll call from package string from. I'll call the function ask it to int. So ask it to int just takes in a string and turns it into an integer. So I'll be passing my s into it. So this one returns two value, the int and an error. I'll just throw the error away. And I don't think there should be an error. So what we'll just do is I'll just double my integer, then I'll return the integer back as a string. So I'll still using string conv. Then this time I'll be using function int to ASCII. Then I'm passing it on. So the function just takes in the string, converts it to an integer. I'm not important string. So it just takes in the string, converts it to an integer, doubles it, then returns it back as a string. So I can pass in my double function here. So I'll modify my expression to match all numbers. So 0 to 9 to match all numbers. So any number in this place, let me put different numbers. Let me put a 10, then random, then a 20, then a 30, and I'm having a 96 also. So when we run this code, we'll be having 10. So 10 becomes 20, 20 becomes 40, 30 becomes 60, and 96 becomes double 96. That is 192. So 96 becomes 192. So when I run the code, so I should still be having this particular string back, but instead of the string, I'm not using package strings anymore. So I'll still be having this particular string back, but all the numbers will have been doubled because that's what our function double does. So yeah, I'm having my string back, but the 10 has been doubled to a 20, 20 has been doubled to a 40, the 30 has been doubled to a 60, and the 96 has been doubled to a 1812. The reason why it's actually a 1812 is because it's actually taking 9 as a number, then doubling it to 18, then taking 6 as a number and doubling it to a 12. So that's why I'm having 1812. I was thinking I was going to have a 192. I'm having 1812. So that is how it works. So a very good situation where regular expressions are actually useful is when maybe you are working on a web API and you need to validate form inputs from users at the front end. So you can just create a function, maybe validate forms. The function validate forms that just takes in the particular form input you want to validate. So let's say as form input, form input, which is a string. Then this one should return a bool. So you can just simply return regexp dot must compile. Then you can actually make it taking two inputs instead of one. So you can take in an expression, then the form input. So you can just compile the expression, then see if it matches the form input from the front end. So this is what this returns. Because from here, if you check our code doc regx, why is this happening to me? go doc regex. If you check our regular expression interface back, our regular expression struct reg regex. So match string actually returns a bool. So we are just compiling the expression and seeing if it matches the form input. So if you have like an input for someone's phone number, for example, and you've gotten the input with r.form value, request form value, form request form value, or whatever way you got it with. So you just check and just say if not valid input, or if not valid form, then you can put in an expression. Let's say it's the phone number you are getting. So the expression for an ideal phone number in Nigeria, at least, because I live in Lagos, Nigeria, so I don't know of other countries, but for Nigeria, a valid regular expression for phone number should be something like a caret and a dollar, then zero, then a backslash d, then. So what the regular expression mean is that it should start with a zero, and after the zero, 10 numbers after the zero, and it should exactly end with the 11th number. So having a zero and 10 numbers, that's 11 numbers. So it should start with a zero and exactly end with the last number, which is the 11th number. So that is the expression. Then the string should be whatever the person has input in the front end. Maybe request, session should be request dot form value. Maybe the name you give it at the front end is phone number. So you can just say page number. So you can just return if it is not valid. That means if it doesn't pass this particular test, then you can just maybe return an error to the person at the front end that invalid phone number or something. Maybe invalid phone number. Then with an error code 400. I think that's status bad request. So I think a 400 is a status bad request, and a 500 is a status internal server error. So that is where regular expressions, that's one of the situations where regular expressions are very, very useful. So that will be the end of today's video. If you are new to the channel, make sure you subscribe and also like the video if you do. And if you also don't like it, you can actually drop a comment and tell me what I did wrong. I might try to do better in another video. So that will be all for now.